All right, hi guys. So just wait. Imagine you meet a question like this. Maybe you're a jam student or you're a post-UTME student. You meet a question like this in an example. What will you do? How will you solve this kind of question? So let's look through the question. It says a block of aluminum is heated electrically by a 30-watt heater. Oh, okay. If the temperature rises by 10 degrees Celsius in 5 minutes, the heat capacity of the aluminum is what? So this question actually comes from a part of physics as is known as heat energy, right? Measurement of heat energy to be specific. And from there, we notice that the quantity of heat exerted on a body is simply the mass of the body times the specific capacity of the body times the change in temperature of the body. Okay, that's the formula. Now, you have to understand there's a difference between specific heat capacity and heat capacity. What is heat capacity? Represented by H. Some book might use under symbol. Specific heat capacity is represented by C. So what is the difference between the two of them? What is specific heat capacity? Is actually the amount of heat needed to raise a unit mass of a substance by 1 Kelvin or 1 degree Celsius. While heat capacity is the amount of heat needed to raise the mass of an object by 1 Kelvin or degree Celsius. They sound similar, but it's different. And let me use this illustration. I have a bunch of broom, right? The amount of heat, broom is not a conductor, so but I don't want to use that one as an example. The amount of heat needed to raise the all of the broomstick, all of them combined, is called heat capacity. But if I take one single stick of broom, the amount of heat needed to raise the temperature of just one stick is called specific. So the word specific means we are considering a single, and that's why the definition says the amount of heat needed to raise a unit mass, not just the mass, a unit mass of that substance, okay, by 1 Kelvin or degree. That's specific heat capacity. So there, when we say the amount of heat, means that this is the quantified heat quantity. So the quantity of heat needed to raise a unit mass is MC change. This is the formula. Mass of that unit mass of that substance, like the unit mass of the substance, the specific heat capacity of the substance, then that change the temperature. But heat capacity is simply the mass times the specific capacity. So if you want to get heat capacity is simply mass times specific heat capacity. So if the question asks you what's the specific capacity, all you have to do is multiply the mass times the specific capacity. So knowing this, if I want to rewrite this formula, my quantity of heat, if they give me heat capacity, to simply be what? Q is equal to H times change in temperature. Is that not it? Where H alone is taking this MC. Are you following me at all? Good. So now let's go back to the question. But before I go back to this question, there's also a process known as heat transfer, right? Remember, we say heat is the form of energy. Heat is actually a form of energy, and we have established we know that energy is not created, not destroyed from the law of conservation, right? Energy can be transferred from one form to another, which simply means that my chemical energy can be transferred to heat energy, my electrical energy can be transferred to light energy, right? Is that not it? So if I on my generator, mechanical energy, that mechanical energy will be transferred through the wire, electrical energy. Then the electrical energy will give light to the earth, light energy. So energy is not created, not destroyed, but it is transferred from one form to another. So this question is, I took a heater. How many of you remember that thing that they used to boil water, that water boiler, electrical? They just plug it to the socket, place inside a bowl of cold water. After like some minutes, you know that the water is hot, which means electrical energy from the heater has been converted to what? Heat energy in the water. So energy is not created, not destroyed, but it can be converted. So based on this conversion, we can simply equate energy together. So if I use that my heat boiler as a case study now, I will notice that there was a quantified amount of electrical energy that was converted to my heat energy, which that's made my water to be hot. So I'll simply say something like this. I'll simply say, oh, my electrical energy EE is equal to what? My heat energy HE. What does this mean? It means that my water was able to boil because some amount of electrical energy was converted to heat energy, and this heat energy made the water to boil or made the water to be hot. Are you following me now? That's what this question is addressing. So a block of aluminum is heated electrically. It was not heated by fire. If it was by fire, now we simply say, okay, that was just heat energy. It was heated electrically using electric by a 30-watt heater. The power of the heater is 30 watts. So first thing we are going to write out here is power. So power of heater P is 30 watts. Moving on, if the temperature rises by 10 degrees Celsius, okay, after the heater heated my aluminum. My aluminum, its temperature rises to 10 degrees Celsius. So change the temperature for aluminum, change the temperature 10 degrees Celsius. Okay, this was done in 5 minutes. So the time it took for this thing to take place, for this aluminum to be hot, was 5 minutes. And remember, it's only in exception we use our time in minutes. We have to convert to second. So 5 minutes in second will be 5 times 60. 5 times 6, that's 30. This is 300 seconds. So my 5 minutes is 300 seconds. It's good to convert a minute to second. Then moving on, they now say the heat capacity of the aluminum is what. So from here, we know that an energy conversion has taken place. Electrical energy to what? To heat energy. So we say electrical energy, EE, is equal to heat energy, HE. Are you with me? Formula for electrical energy. I have taught electricity. Go and watch a video on it. Just go to my YouTube tutorial that I call Current Electricity 1. I've taught it. Go. You see formula for electrical energy. So formula for electrical energy is power times time. PT, that's the formula. Power times time. What's the formula for our heat energy? Normally we are supposed to use MC change the theta, right? But then they say heat capacity. I just showed you another way we can write it instead. So instead of saying MC change the theta, I will simply say H times change the theta, where my H here is representing what? My heat capacity. I can't use MC change the theta again because that's not what the question wants me to find. The question wants me to find the heat capacity. So my H here represents my heat capacity. So by making H subject to the formula, my formula will become H is equal to change in theta over power times time. What is the change? Change in theta is change in temperature. That's 10 over, what is my power? 30 times time. What is my time? 300. So if is there anything I've not converted? Is it 30 watt or 30 kilowatt? Okay, let's just move on. If I solve now, I find out that 30 times 300, right? Oh, sorry. I was looking at the answer. I was like, oh, this will give me a 0.00 something. Sorry. Mistakes like that happen actually, because if I make H something of the formula, it will rather be H is equal to P times T over change. These are because I was looking at it, I was like, oh, I'll get 0.000, and there's not like 0.000 here in the option. So this is how it's supposed to be, because if I divide both sides by change the temperature, I'll have P times T over change the theta. That's how it's supposed to be. Sorry about that. So we'll have 30 times 300 over 10, right? This is it now. So 30 times 300, right? That will give you 3 times 3 is 9. That will give you 9,000 over 10. 10, that's 900 joule per Kelvin. 900 joule. The correct answer to this is option A. Sorry about that. That's simple mistake. These are what I'm actually trying to say. Don't rush. Calm down. Many students make mistakes in an exam. They will know the thing and just solve. Not be confused. So please don't rush your exam. Sorry about the mistake. Actually, I didn't realize, because I realized at that point, I noticed that, oh, if I divide this, I will get 0.00, and there's no 0.00, and that's how I had to pause that. Is there something I'm not putting? And then I realized that I made a mistake in my cutting short this thing. But this is how it is. So as simple as that. So this is actually not difficult. When you see a question like this next time, you should be able to speak. But nonetheless, I'm going to be making a video on heat energy on itself, and I've made several videos on YouTube. Simple harmonic motion, some other videos. You can check my YouTube channel, full video. You don't need to study your textbook. Just go there, watch the video, get your example. I'm gonna be solving question. You will love it, I'm telling you. Meanwhile, I am a tutor Glycol. If you have seen this video on TikTok or anywhere, just make sure you follow me so that you get more videos like this and other things. Thank you so much for watching. Subscribe to our YouTube channel. And yes, if you are a JAMB student, that's a student preparing for JAMB next year, or you are a science student that's struggling with chemistry and physics, we have programs for you that can help you. In 2 months, you'll be a beast in chemistry. Yeah, I'm telling you, I've taught students like that who eventually became beasts in their field. Sorry for using the word beast. Beast means that like you'll be a guru. Yeah, exactly. So if you have challenges in physics, chemistry, and all the rest, just make sure you send me a message on WhatsApp so that we can help you. 07036 59 30 57. We have programs for JAMB students, YX students, post-UM students, or if you want a private classes too, we also allow that. So just make sure you follow us. Thank you for watching. See you in our next video.